Hello, good day. So welcome to this lecture video. So this is the continuation of the lesson on non-parametric test. So as you can see in our screen, our objective is to answer this question. So is there a significant difference in the classification of the BMI of the selected employees in company X after undergoing a dietary program, or after undergoing a diet plan program? So in our given data, so we have here the encoded data, the BMI before and BMI after. So if we will just go over with our values to determine what is the data, the data here means. So we have here numbers like 1, 2, we have data 3, 4, 5, 3 until 5 and 13 number of respondents. So of course, we have the data before and the data after. So they were, so the situation here is that they were assessed in terms of their weight and then their height, and then the body mass index was computed to determine what is their classification of the BMI. Then afterwards, the same procedure was conducted, and we are going to see how effective is the diet plan program given to the employees. So as we can see here in the values, so 1 means underweight, 2 means normal weight, 3 means overweight, 4 means pre-obese, 5 means obese type. So if we will go back to our data and sort this, right click, sort ascending, so just to see if what is the minimum and the maximum number. So the minimum number is 3 and the maximum number is 5. So which means there is no number that exceeds 5. And just to know what is the values for 1, 2, 3, 4, 5, we can refer to this article showing the nutritional status based on the World Health Organization's and Asian criteria values. As we can see here, it's considered underweight if it is less than 18.5. It's normal weight if it is 18.5 all over 22.9. It is overweight when it is 23 to 24.9. Pre-obese if it is 25 to 29.9. Obese is greater than or equal to 30. Obese type 1 is 30 to 40. Obese type 2 is 40.1 to 50. Obese type 3 is greater than 50. So the one that we use is the Asian criteria. So how did we get the value of the BMI? So just to have, of course, an idea of how this is obtained, as mentioned, you have to get the weight and the height of the respondents, and afterwards compute the BMI. The formula for the BMI is equal to weight in kilogram all over height in the meter square. So from this value, we can now classify the values whether the respondents belongs to a nutritional status of overweight, pre-obese, and others. So as also emphasized in the given program, so it's a dietary plan program or a diet plan program, which means as again also going back to the data, we see that the number or the lowest number is 1. So this means that if we will just place the coding scheme here, 1, 2, 3, so most of our respondents or all of them obtained a nutritional status of at least overweight. So we are going to see how effective is this diet plan program. So let's go back to our data. So what possible tests can we use to solve this problem? So assuming that, of course, we do not have access on our data computation of the BMI, and we are just given the data on its classification, the one encoded in our data set. So our data is ordinal in the nature. Remember that if our data is no longer a numerical or it's no longer at least interval, we cannot use parametric test. So maybe you are thinking of t-test for paired sample. So in this case, we cannot use t-test for paired sample. So what alternative can we use? So initially, your assessment is to determine first what is the number of respondents. So we have 30 respondents. So since we have 30 respondents, it's also possible that you might think that by central limit, this data is normally distributed. But we do not have rather concern about it because remember, as mentioned, we did not already satisfy the first condition, which is telling us that the data must be at least the interval. So in this case, we cannot really use parametric test. So with that, so the test that we are going to use is the counterpart of t-test for paired sample, which is the Wilcoxon Signed Rank Test. So let's just emphasize it here. So let me just consider that or reiterate that non-parametric test will be used because our data is, it is not at least interval. Particularly, our data is ordinal. So even if the number of respondents or the sample size is 30, so this does not mean that the data is normal. So, or even because of course, going back here, our data is ordinal. So we are not concerned if the data is normal or not. Because it is not at least interval. Therefore, we will be using parametric test. Particularly, we will be using the counterpart of paired sample t-test, and that is the Wilcoxon Signed Rank Test. So we will be using Wilcoxon Signed Rank Test. Okay, let's do it. So how will we generate the table? So click Analyze, Non-Parametric Test, Legacy Dialogue, and so it's not independent samples, it's paired samples. So which means we will be using two related samples. So let's click this. So let's pair BMI or maybe BMI 4 and BMI after. So maybe let's just first correct our measure so that you will not be confused. This is ordinal. So let's just repeat the step. Analyze, non-parametric, legacy dialogue, two related samples. So we will be transferring this. Of course, we will be asked to place the pair, and the pair is the after. So we have here again several tests placed, Wilcoxon, Signed, McNemar, marginal homogeneity. But as mentioned, the counterpart of t-test for um, t-test for paired sample is the Wilcoxon signed rank test. So just click OK. So this is now the result of our test. So let's copy this. So what is this table telling us? Transfer it in our Word document. Okay. Okay, so let's continue. So this table is telling us the number of negative ranks, positive ranks, size, and the total. So if you like, in place of the negative ranks and positive ranks, you can also show this by presenting the median of our BMI after and BMI before. Because, of course, as also in our previous discussions of non-parametric tests, we mentioned that whenever we are using non-parametric tests, since we can no longer use mean because it's not appropriate for the data that is not normally distributed, we can use median. So I'll just also place here an alternative table that can be used. So you can also use the BMI before and BMI after, and then you can present its median, and then afterwards you can present the result of the Wilcoxon rank test or the test is statistics used in this study. So this is an alternative, but you have of course to generate the median if you will be doing this. Now, if we will be using the result of Wilcoxon signed rank test, so it's your option if you would like to consider placing the sum of ranks. Because here, when we are presenting this, it is showing us the frequency. So this is with a superscript A, meaning BMI after is less than the BMI before. So there are 25 of the respondents with higher BMI before and then lower BMI after. And then with superscript B, it means that the BMI after is greater than the BMI before. So as shown in our table, it is 0, which means that no respondents have a BMI higher before the conduct or higher after the conduct than before its conduct. While for ties, so this is saying us that the BMI after is the same with the BMI before. So there are 5 cases or 5 respondents for that. So let's move. So let's see. So where is the generated table for this? This one. So this is our concern. So the asymptotic significance using the Wilcoxon signed rank test is 0.000, indicating a significant result. So let us emphasize that. So we can see here that P is less than 0.01, which means it is significant at 1% level of significance. So Wilcoxon signed rank test can also be represented using Z. So Z is equal to negative 4.548 and with a superscript B indicating based on the positive rank. And P is 0.000. Let's place this with double asterisk because later it's also very useful or it's commonly used in the presenting tables asterisk, asterisk, double asterisk. So if it's just simply one asterisk, it means it's significant at 1%. And if it's double asterisk, it is significant at 1%. So if it's one only, it is significant at 5%. But you have, of course, to place that under the table. So assuming that this is already the table that will be shown, so you have to place double asterisk significant at 1%. So we will just, you can actually just simply continue this test statistic. So Z is equal to negative 4.548. P is equal to 0.000 and place double asterisk. So this is the result of our table. Okay, so it means since we can see in our table that after the dietary plan program or a diet plan program, all or rather majority because we have 5 respondents with the same number of or subjects rather because they are the subjects. So there are 5 subjects with same classification of BMI even after the diet plan program. So 25 of our subjects improve their BMI, so which means it lowered after the diet plan program. So indicating also that it suggests rather that the diet plan program improved, which means it decreased their BMI classification. Of course, because our objective here is to lower their BMI classification because they have a very, very, very high indicating obese, overweight, obese type 1, and even obese type 2. So this ends this discussion. Thank you for watching.